Now we come to the second part of the video for today's asynchronous lecture. Tadi dalam first part of the video, we have solved for first order differential equation kan, and now for second order differential equation, as I told you, okay, we have find the R where we get R is plus minus root of minus lambda, and this lambda is still unknown value where it depends. There are three possible values of lambda, where lambda more than 0, equals to 0, or less than 0. Okay, so we got to check, okay, whether our boundary and the initial condition satisfy the case for lambda more than 0, or lambda equals to 0, or lambda less than 0. If lambda more than 0, then our Vs is equals to this one. Okay, Vs equals to C1 cos lambda root of lambda x plus with C2 sine root of lambda x. Okay, and then if lambda equals to 0, then our V is equals to C2 plus C1x, and if lambda less than 0 equals to this one. Okay, C1 cos plus with C2 sin as shown here. Okay, so now what I'm going to do is to proceed with this example, and we go case by case. Okay, let us consider the first case. If lambda more than 0, then our Vs equals to this one, right? Okay, our Vx will equals to, okay, Vx will equals to C1 cos root of lambda x plus with C2 sine root of lambda x. And remember, we have, okay, this is for lambda more than 0. For lambda more than 0. And now we are going to check with the initial condition saying V0 equals to 0. Maksudnya kita gantikan into this equation x equals to 0. So we have sine, cos, definitely everything turned out to be 0. Okay, cos 0 lah maksudnya. And then plus C2 sine, lambda ni pun gone, sine 0. So sine 0 we know is equals to 0. So gone together dengan C2. And this one cos 0 is 1 kan. So dari sini kita dapat C1 is equals to 0. So dapat dah value C1 is equals to 0. Then we have another boundary condition. VL is equals to 0. Okay, so this VL equals to 0. We're going to have C1 cos root of lambda L. Gantikan X2 dengan lambda. And then plus with C2 sine root of lambda L equals to 0. Ni 0 dua kali 0, tak apalah. Tadi we have C1 equals to 0. So definitely yang kat sini pun dia akan 0 lah. So what we left with, we have C2 sine root of lambda L equals to 0. Okay, then dari sini kita nak cari apa ni kelas? Kita nak cari value of lambda. We want to find the value of lambda. Okay, so let's have a look. So dari sini kita tahu C2 sine lambda L equals to 0. So again kat sini C2 ni akan gone. Dia akan jadi kosong bila pergi ke belah sana kan. Bukan jadi kosong, dia akan hilang. Okay, we don't know what is the value of C2. Then what we have is sine root of lambda is equals to 0. And we know sine of what is equals to 0? Sine of n pi is equals to 0. Daripada chapter 4 lagi kita dah find out yang ni kan. N pi, sin pi kosong, sin 2 pi kosong, sin 3 pi kosong, sin negatif pi kosong, sin negatif 2 pi kosong, and so on and so forth. So dari sini kita tahu root of L is equals to n pi. Then we have lambda will equals to n pi over L square. So in this case, we have satisfy the condition. Kita dah dapat value of lambda. Okay, we have satisfied the condition for VL equals to 0 and V0 equals to 0. Dari situ kita dapat value of lambda and come to our knowledge C1 ni sama dengan kosong. C2 kita tak tahu berapa value dia. It's okay, tak apa, biarkan. So we have Vx equals to C2 sin, okay, C2 sin square root of lambda. Square root of lambda ni sekarang kita akan gantikan dengan n pi over L root square, okay, x. Okay, so that is our Vx. Okay, so maknanya kat sini kalau ikutkan square root dengan square ni dia akan cancel each other kan. So kita akan dapat C2 sin n pi over L n pi x over L. So this, it seems that for lambda more than 0, we have a solution. Our Vx equals to C2 sin n pi x over L. Tapi kat sini, I would like to remind, sebab kita bukan lagi berada pada last solution. We have not yet come to the end of the solution because we still got to check for lambda equals to 0 and lambda less than 0. Bukan kata bila dah dapat lambda more than 0 ni, it satisfy the boundary and the boundary condition and the initial condition V0, VL2 kita dapat, then we can stop. Okay, we don't have to check for lambda equals to 0 and less than 0. No, you still have to check, and we haven't come to the final step yet. So maksudnya kat sini kita at the end of the day we will get one constant. So this one C2 ni kita boleh kita boleh omit dulu, because at the end kita akan tambah dengan satu big constant. Sama juga dengan sebelum ni kita ada discuss kan, kalau ada C kita boleh kalau e power of C we can disregard e power of C, we can just replace with one big C. Macam tu lah dia punya tu. So as of now you can write C2 sin n pi x over L, ataupun you can just write sin n pi over L x. C nanti kita akan replace it with another constant. Okay, that we will discuss later. Alright, so clear everyone for lambda more than 0. Now let's proceed for lambda equals to 0. Okay, for lambda equals to 0, we have seen the solution is going to be C2 plus C1 x kan. Kalau kita consider lambda equals to 0, then the solution will be C2 plus C1 x. Okay, let's proceed. Okay, lambda equals to 0, then our Vx is equals to C2 plus with C1 x. Okay, okay, so again kita akan check dengan kita punya initial condition. When V0 equals to 0, so C2 plus with C1 times with 0. So in this case it gives us C2 is equals to 0. So C2 equals to 0. And then kita ada VL is equals to 0. Then we have C1 plus with C2 darab dengan L. And come C2 balik C2 C1L. Okay, C2 C1L. So tadi kita dah dapat dah C2 equals to 0. So we have C1L is equals to 0. So maknanya apa sekarang? We don't have anything, right? We couldn't come up with any equation. We just have C1L equals to 0. We call it a trivial solution. C1 can be 0, L equals to 0. Kita tak pasti. So meaning that we come to the conclusion that lambda cannot be equals to 0. So meaning that there is no such solution. Vx equals to C2 plus C1 x. Okay, so it doesn't satisfy the boundary and initial condition. Okay, so now kita consider third case, lambda less than 0. So for lambda less than 0, ni dia punya equation. Vx equals to C1 cos root of minus lambda x plus C2 sin root of minus lambda x. So kita akan ganti V0. Okay, V0 equals to 0 kan. Okay, C1 cos 0 plus with C2 sin 0. Okay, sin dengan cos, jangan keliru dengan cos and sin. Cos x dengan sin, cos x is different. This cos ni is a hyperbolic function, yang ni trigonometric function, is not the same. You may refer to the calculator, ataupun saya ada bagi dalam sheet tu definition of cos and sin function. Okay, so cos 0, fortunately dia nak sama dengan cos 0, which is 1. Sin 0 is 0. So dari sini kita dapat macam tadi juga, C1 is equals to 0. We get C1 is equals to 0. Then now kita ganti for VL, kita dapat C1 cos minus lambda L plus with C2 sin minus lambda L. And we have the knowledge that C1 is equals to 0. Again, yang ni kosong. Then this one is equals to 0. Okay, listen carefully this part. C2 sin minus lambda L equals to 0. So there are two possibilities that will make this function equals to 0. Am I right? Sama ada C2 tu sama dengan kosong, ataupun sin minus lambda L equals to 0. Alright, so dari sini kita check, okay, if sin minus lambda L equals to 0, okay, equals to 0, maknanya benda yang ada dalam ni, okay, if we say that sin root of minus lambda L equals to 0, maknanya benda yang dalam ni should equals to 0. Okay, benda ni, okay, there are sama ada L ataupun root of minus lambda ni yang akan sama dengan kosong. Okay, that will make the function 0. Sin ni should be equals to 0, maknanya square root of minus lambda L should be equals to 0. L ni impossible ada kosong sebab is a period kan. Dia punya panjang apa tu the length of the tempo of the function. Okay, so that is mean that lambda yang should be equals to 0. However, what case is we are considering now? We are considering lambda less than 0. How come lambda ni akan jadi sama dengan kosong? Dia dah jadi contradict. Betul? Okay, because we are now considering for case lambda less than 0. Suddenly kat sini kita kata lambda is equals to 0. So in this case, meaning lambda cannot be equals to 0. Meaning that sin of root negative lambda L cannot be equals to 0. In that case, maknanya yang menyebabkan this function equals to 0 is C2 equals to 0. So kalau C1 sama dengan kosong, C2 sama kosong, what is our Vs? We have nothing for our Vs. Vs just simply equals to 0. Okay, clear everyone? So in that case, lambda less than 0 is not also a solution to Vx. Okay, it's not a solution to Vx because it does not satisfy the condition VL equals to 0 and V0 equals to 0. Alright, so with that, I think I make your hopefully I make you all clear about that. So dari sini maknanya as a conclusion, we have for lambda more than 0, yes, we have our Vx is equals to, tadi kan kita dapat apa? C2 sin n pi x over L, right? For lambda equals to 0, no solution for Vx, kan? Okay, it can't satisfy because we get C1 and C2 gone. Okay, and lambda less than 0 juga, we have no solution for Vx because we get as what I have explained to you. So dari sini maknanya kita dapat our solution Uxt is equals to Vx times with GT. Tadi saya dah solve for you your GT, kan? We have solved for you your GT yang mana Vx ni, tadi saya kata C2 ni boleh cancel and tinggal sin m pi x over L. Yes, it's true. Okay, tapi saya nak explain kenapa dia boleh cancel tu. So saya bawa dulu sekali C2 sin m pi x over L. And tadi kita ada kita punya GT kita is equals to C, betul tak? C, kan? Kita punya C e the power of minus lambda kt, if I'm not mistaken. Betul tak? Betul dah rasanya. Ni. Okay, C, oops. Alamak. Okay, this one C e power of minus k lambda. N tu sebab oops. Okay. Ni C e power, C ni maknanya C yang belongs to GT. C e power of minus lambda kt. K here, okay, kt is, K is a constant. A ni is lambda n. Okay, lambda n. Okay, and because this one is n pi x over L. Remember this one, m pi L ni adalah kita punya lambda, kan? Okay, lambda kita adalah square root of n pi over L tadi. Sorry. Lambda is not equals to m pi over L. Lambda is equals to m pi over L square, kan? Okay, check balik on the video yang saya cari for the case lambda more than 0 tu, kita dapat lambda is equals to m pi over L square. Okay, yang ni dia jadi m pi over Lx je sebab it's root of lambda. So root dengan square tu dia cancel each other, kan? So maknanya kelas kat sini, okay, kat sini lambda tu you boleh gantikan dengan m pi over L square. So meaning we have C2 sin n pi over L x darab dengan C1 e power of minus lambda yang ni adalah n pi over L square, okay, kt. Okay, and as you can see now, Allah, okay, we have two constant. Okay, we have two constant. Okay, where we have C1 and C2. Yang ni yang saya maksudkan tadi. C1 and C2 ni kita boleh biarkan, and instead we replace with one big constant. And for this case, that big constant I denote as Bn, because the constant also depends on the nth term of the function. Okay, so that's why the final answer will turn out to be Bn sin n pi over L x e the power of negative k, nak suruh cantik sikit, n pi over L square t. Alright, so this is our final answer finally for our partial differential equation given in starting daripada example 3, kita stop, then we continue in example 5. Okay, so kalau you tengok dekat jawapan mana, kat jawapan yang diberi pun mana dah jawapan tadi. Okay, this is the answer given, kan, where n is equals to 1, 2 and 3. Okay, and I think I have answered all here. Why suddenly there are n, un and bn here? Because our lambda is all starting from sine root of lambda x is equals to sine of n pi. There are so many possibilities. So we consider for the case n equals to 1, 2, 3 and so on. But here we have lambda is equals to, okay, n pi over L square. So that's why kita ada datangnya n kat sini. Okay, then we have Bn, and this B comes replace C1 and C2. Okay, so we have solved example 5. Hopefully I make yourself clear. It's quite a long step, but if you understand every single step, then everything will be fine. Okay, so that's all for the second part of the video.